friends. Hello and welcome to the very first episode to Getting into Good Oxide. Hello, Sydney.
Hello, Sebastian. Thanks for having me once again.
Yeah, after our great season, our first season, where we got into Rust with a little bit of Good Oxide, now it's time to actually get into Good Oxide. Now that Rust is an open book and everything is totally clear, right?
Yeah, absolutely. I can't wait.
Yeah. Also, it's all very easy and lifetimes, no issue, all this kind of thing. Very straightforward. Send and sync anybody, of course. Give it all to me. Send, sync, and static. And I guess everybody who wants to get into Good Oxide will have to start cloning this. So I just do the same thing. So we start fresh. And that's actually pretty fast. Nothing to talk about in the meantime, except for, yes, it's pretty fast. And one day maybe you can use Good Oxide to clone Good Oxide. So it goes all the way around. And now that we have it, you open it in an IDE of your choice. IDEs. Which IDE would you use for Rust? What's your preference by now?
I mean, I usually use VS Code, and I guess I haven't had that much experience with developing Rust in there, but I think like the tooling works pretty well for what I experienced. So yeah, VS Code is my choice.
VS Code works. We could open that, but there I don't have presentation mode set up. So I just open it in IntelliJ, which to my mind has still the best refactoring tools. This is why I use it all the time, especially renaming and so on, moving things around, because I move things around so much. Yeah, getting things right the first time is hard, especially if you don't really know what you're doing and how things want to be. IntelliJ definitely helps. Okay, so once you have your clone, how do you get started? I mean, sure, there's a bunch of files. I think what you can try to do is use the right command to get into Good Oxide, literally with cd. And then there's this top level makefile, which I love because it prints out, oh, it's wonderful. I can't scroll in this view. Ooh, okay. Let me fix this. So here we are in the same thing, but it's my working copy instead of a fresh clone. Let's go with the makefile again. And here you see there's a bunch of stuff to use. Something worth checking out to see if you can build properly is certainly make tests. And that can take some time to make tests because it does a lot of stuff. It should only require a Rust compiler, stable Rust compiler, nothing special there, but sometimes it might pull in some dependencies which are C, and then you need other tools like CMake, and I don't know that anymore because I'm kind of set up using Homebrew on macOS. So if something is missing, brew install what's missing. I guess that's the easiest. I tried Nix. I also have Nix on my system, which right now helps me to work around my linker not working anymore. This slows down everything, unfortunately, but Nix also works. That's what I'm saying. You can use Nix to get everything you need to build this, but it should be relatively straightforward, especially with Homebrew. Okay, make tests. And that's usually what I'm doing. So without saying too much, if I want to push something, this is my command line. So I make tests, then I check the size, and then I push. And that's all. And these tests, they can run for like 5 minutes, even on a fresh cache. Should be faster, but right now everything is kind of slowed down for me. For you, it's probably faster, but it does take some. All right. Now that you can build things, what are you gonna do? Is there anything you should know about like all of this? There's so many things here. And I think this brings me to the next topic. There's a lot of written and up-to-date documentation beyond the makefile, which, you know, make tests is usually it, which is all these markdown files. So I guess most people will come from the README, and it's definitely worth reading because it contains the project goals and non-goals, and that might be interesting for you to know in case you want to contribute something. Also what the current status is. Where's the status? Here's a crate status. So what's usable in case you just want to use something, right? So all of these crates, they're published, so you can just look them up on docs.rs. Let's go with git ref because I've been recently working on this. And here you find a recent copy of it. If you find it on crates.io by now, everything is documented. I think most documentation is okay. Could always be better, I'd say. It should be okay to get into, but don't expect awesome documentation just yet. I think it's okay. As I write down what I know, and I use it myself sometimes to understand what the heck I was thinking there. So this is the state where the project is in as well, that there's so much by now that I do have to rely on my own documentation for sometimes not forgetting details and so on. So kind of a lot, and counting, of course. Let's see when the 100,000 mark will be hit, but still a long way to go as well. Less is more, right? But kind of an indicator. All right. Then with these markdown files, once you have checked the README, I guess the first thing that you notice is that there is some notion of stability. There's 2 tiers of stability, actually 3. Stability tier 1, tier 2, and tier 3, which is the in development or pre-release mode. And I guess to get an overview of Git Oxide itself, it's really useful to have a look at, do I link to that somewhere? At the stability guide. The stability guide is this one here. Maybe I should use the markdown preview mode for this to look a bit better. And I developed this to understand a bit better how the crates depend on each other and what that means for stability. Like, can I just say once it's 1.0, it never changes? And what's the kind of changes I can make without bumping the major version? What does that mean for all these crates that are called foundation crates? Because if I say this is stability tier 1, does everything else have to be stability tier 1 too? Because that depends on each other. Answer, yes. So the plan is that all of these are stability tier 1, which is the highest stability level. And I just assigned some more or less, random numbers to that. So in stability tier 1, you can only, how can you do that? You can make breaking changes only every 6 months. So, I thought it was a nice number and doesn't lock you in too much. And ideally that number goes higher and higher. So you collect breaking changes if they come up, but you keep them away for half a year, and then eventually you release them. That's just an idea that I want to actually uphold, but only once things are 1.0, they are stability tier 1. Then there is stability tier 2, that is release plumbing crates as opposed to these app and application crates. So here, so application crates, that is Git repository and Git Oxide core and the actual apps. So that is tier 1. And the foundation crates that they're using, that's also tier 1 because they're usually exposing these types. So they also can't just change at random. It has to be kept compatible. This is why. But all of these crates, or the Git repository, for instance, may use internally, ideally, these plumbing crates, which are not directly exposed. And if they get exposed, then they have to be stability tier 1 as well. So right now it's a bit unclear what has to be exposed and what not. But I think the more Git repository will be used, the more clear it will get. So far, I'm sticking to that. So you will have to turn on some unstable feature toggle for stability tier 2 to become available even through Git repository, because Git repository, as you can see, it's kind of this top level thing that seems to pull in everything else. And that is indeed the case with different stability levels. And I will see how well all that works in practice. But it seemed like the right thing to do, as ideally the least amount of crates has to be very, very stable, so that there's still a good bunch of crates that can change more often, especially initially. So that is the purpose of these two stability tiers, whereas tier 3 is basically most of the crates right now pre-release, and there everything goes. You can do what you want, but of course you have to stick to semantic versioning. So that's it. That's a high-level structure, that's stability here.
That makes sense. So basically, right now, for the beginning, everything is pre-release, and it will move, or you will try to move as much of it into the stability tier 1, and then see how you can split it up. So what needs to be more important and what doesn't.
Yes. So it's still a bit in flux, but I already stepped forward and said, okay, what can I possibly make stability tier 1, stability tier 2, just to have some dogfooding going on there. And these are the ones. Git lock as stability tier 1 crate, because it seems to be done, as it covers all the features that the Git lock implementation has within Git, and it can do everything it needs to do to do its work within Git ref, which uses locking mechanism a lot to write files as atomically as possible, with that kind of consistency level, like as good as possible, but it's not perfectly consistent. Git temp file is used by git lock. So git lock is really just an abstraction on top of a temp file, and that is not exposed. Hence its stability tier 2, because it's a released plumbing crate. So ideally, the more clear it becomes what will not change anymore, what's good, let's say, what's there already, these can then be elevated to stability tier 2 and maybe even stability tier 1 if they're exposed directly by Git repository. So that's pretty cool too, to be honest, because before that I didn't have a plan, let's say, for stabilizing things. And it's of course nice to just be able to change things and then you make a new release, breaking things possibly, but yeah, Git Oxide wants to be used, thus it must be clear how much you can rely on it, how stable things are, and how often it will try to break your build. So I think it's worth highlighting that those who want to use Git Oxide, most of the people, let's say, they would use Git repository, as it's supposed to be used as use Git repository as Git. So then you can use the Git namespace to say Git repository open or discover or this kind of thing to open your repositories and work with them with an API that is very fluent, very natural, very comfortable, hiding all the nitty-gritty details that are actually exposed in these foundational crates, as to, not mess around with thread safety and delay decisions about what's sent and sync to later. So ideally, this is all just pure functional stuff, and people can build abstraction on top that then make decisions and trade-offs that are just not made here. So here you can get the best performance, whereas here you have to make some trade-offs to ideally get the best possible performance and the best possible comfort level for what you are doing, with a given set of trade-offs, which ideally is be as nice to use or nicer as libgit2 or git2, the git2 crate, which is pretty nice already, if you ask me. I like it. Of course, I think now that you have the baseline, you can always improve on the baseline. That's the benefit of being second, so to say. libgit 2 is already an awesome library in itself, even though I really don't like their documentation, but the Rust documentation that sits on top is already a step up from that. And I think that's a good place for a Git repository to come in and see how things can be even more idiomatic, for example, how they can be even more rusty, while of course being faster in the light of multi-threading applications with hundreds of cores, right? So this is the kind of thing that Git repository will
So stay on your cat.
Hello.
Go to bed at 9, get up at 4.
Oh. Connected with my husband.
Oh, can you hear? Oh. Hi. Okay. What about now? Now it's better, huh?
Mm-hmm.
Now I hear you too.
Everything.
Thank you. Thank you, AirPods. I don't know how I can protect myself against my wife's AirPods. I don't think do not disturb. I don't think they care about do not disturb, even if I had put it on. All right. And
They just take over.
They just take over everything. I think I removed them multiple times already, but yeah, I will do that again. Okay, cool. That's the first episode. We won't redo this one. So now that you know where to write your first, or where to put your code changes and make your first PR, because you have had a look at these tiers and these grades from the top level, I definitely recommend you to have a look at this collaboration guide. It's actually just this one page. That's nice, even though it's pretty wordy already. It says, yes, be free in what you do. Most contributors will start out as PRs, even though I tend to sometimes push into main if I know exactly what I'm doing. I create a PR for that as well to make this a bit more guided and allow feedback on what's happening there. Usually this even starts with an issue. So by now, what I do is I have a template here where I just put the issue number of the top level issue. And from there, I then spawn PRs into which branches and PRs into which I push. And then I can have multiple PRs per issue if I want to, if there's some sort of sub-task thing going on. But the commit message always contains the one ID of the issue that it kind of all relates to. So GitHub tracks the PRs for me automatically, but I just keep issues related to the commit, or commits related to the issue. Because what's pretty cool, I think, is that change logs are generated in this project, but with a twist, so that you can really help creating change logs by making as many commits as you want. But if you do, ideally you associate them with an issue using this kind of syntax that I've shown before, parenthesis and then an issue number like this, because then it will be linked automatically. It's interesting that here sometimes apparently the commit details are missing. Maybe I removed them or something. That could be because this is user editable. It just starts out giving you a whole bunch of stuff, and then you can remove individual sections and it will not bring them back. You can edit the changelog yourself and so on. But what's most important for contributors is probably not necessarily editing the changelog, even though they can, but it's to just leave Git conventional commit messages. For instance, here. So recently I've done some work on git ref, and I used git conventional style here to just say, okay, there's a new feature. Add this method here and an associated issue number. And now if we would look into the changelog of git ref, we see that, yeah, this is actually added here. This already has been added, and this was done automatically. I only added this part here, so a little bit of a write-up on what really changed, the high-level information. Oh, interesting that this passed here. Usually I have something there that prevents this from going through, but I think I broke that again. So yeah, needs more tests for sure. Cargo smart release. But here you see how things are organized by issue, how all the commits can be seen here, and they're linked as well. So it's basically a complete changelog that, yeah, is providing some interesting insights in how often releases are done, and contains everything usually if you do your commit messages right. But only do these git conventional commit messages when you are done with this, when you want to highlight that this is now there. And so that ideally there's only one showing. This is not perfect, of course. Sometimes you add something and then you change it. So you can't usually change commits, even though you can, right? You could just edit the whole PR and then change the message. And probably that's actually a good way to go. That once you know that you changed something later that was previously described differently, that you then adjust the commit messages in a rebase or something like that. Alternatively, somebody has to remember to fix the changelog later. So of course, all with its ups and downs. What I also noticed, I'm dogfooding this, of course, so I'm kind of running into all the little issues also with the workflow. Not usually your problem, but what really helps with commits is if you make a breaking change, then usually you have to adapt some other crates that would otherwise not compile anymore in the light of the breaking change. So these commits have to be separated so that the breaking change itself is signaled as breaking change, like this here, change with an exclamation mark. This is now a breaking change. And this is, for example, only for git ref. And all the adjustments you do, or for instance in Git repository, they go into a separate commit. Because otherwise Git repository will think there's a breaking change, even though there might not be. It just adapted to some plumbing crate or something like that. So that's that. I fell for this multiple times already, but by now I think I'm remembering to do this correctly. So changelogs are always hard, I think. But I also know that, or I also feel that it's easier to use commit messages wisely. You also see that, or it's easier to use commit messages wisely. At least while I'm writing this, I kind of know what this is about, and I don't forget that way. Yeah.
It might probably take some time to get used to, really. But yeah. I think once you do, you work in a more structured way. Like it's a necessity for this. So I guess overall a really big benefit.
Yeah. I can also say that if it's forgotten, I mean, breaking changes should always be documented in that way. That should not be forgotten. But if some other things I'm not adding, making it into the changelog, I can always check the listing there and probably figure things out from here, like the commit list, like that, and recover some information from there. So as long as there's a decent commit message, I think changelogs can be done nicely as well, even if it's not automatically added to new features or something like that. So that will be fine. And yes, it's a thing I don't always do because not every commit is for the log. It's just, some other things that are not really user facing just yet. And that's Git oxide and commit messages. Anything with that knowledge, I mean, you would already be able to create your first PR and create a nice PR without any issues. The tests, they run and they're not flaky as far as I can tell. They work most of the time. So it's pretty okay, pretty okay experience. If it runs locally for you and you don't do anything with Windows, like, you know, slashes, backslashes, sensitive things, or new line sensitive things, then you can expect CI to work if it works for you locally. That's my experience, at least. So quite painless. Yeah, that's I think the high level overview. That's all. Everything else is coding if you want, or reading docs if you want to use Git repository. And maybe that's also something we can see if that would work if you wanted to. Git repository. Yeah, you see, there's already some documentation that I wrote to explain the overall architecture. I think that's something for another episode, though. It's just that lots of it is still unclear whether this will be the final version of it, whether there's better ways, and so on. So my feeling is, oh, interesting. This means there's a lot of features not enabled, so I can probably configure this, configure docs.rs to build with certain features by default. I just didn't do that yet, see? These kind of things, that would be also be a nice PR, I guess. Low-hanging fruit for sure. And maybe also something I don't forget, so I can maybe even do it when I have 5 minutes or so. But all of this is always, you know, I always try to simplify and find easier and better ways. And I think things here are going to change as well. Maybe even greatly, because there's lots of different types and things to consider. And I think maybe you don't need that. And that's the thing I want, that it's kind of painless by default and you can just use it without thinking too much while still giving you great performance and safety. And I think this is what Git repository can do, even to the point where you use it on the server. And this is really what I want. So it's so good that it doesn't really trade off performance at all. It's more like make it really nice and usable so you can be productive in applications and when developing in next GitHub. Or you decentralize Git. You know, recently on Hacker News there was this idea of, yeah, how would decentralized federated Git be? Yeah, it just needs a server, right? But nobody really has a server except for, well, GitLab has a server, but I think it's Ruby and, you know, all this stuff. Git is Go has a server, but I think they might use Git applications, but there's no, or rarely, let's say, a pure, just one binary kind of server that does it all. But soon there can be. So ideally, all of this just works as another application. Why should the server be special and should use low-level plumbing all the time? Maybe some might do because they want to have their own abstractions, and that's cool. And that's another powerful aspect of Git, of this setup, right? That it's different crates with different abstraction levels. But ideally, or let's say I want to build a server kind of thing on top of Git repository, because then I get to dog food it as well, and it gets to be as fast as it has to be and gets to be useful in a threaded context for sure. You don't want to make mistakes there, right? It shouldn't be having race conditions or something like that as much as possible. So yeah, that's going to be neat, but probably not entirely stable just yet. I'm working on a few things here that will probably mix that up a bit to the better, in the sense that I think a bunch of this, maybe even everything except for repository, will actually disappear and nobody will miss anything. So still looking into this. Yes, but that could be it for our first session.
Yeah, cool. I think that's a great overview for the beginning, you know, just getting into the docs, knowing that there's, even if it's still going to change, there's a lot of information in there. And yeah, just the general README files that you've already provided. So simple as it can be.
One more thing, just because, you know, if you were to use this like what happens if something breaks? Because I keep saying, yeah, it's going to change. So is it going to break you all the time, right? Like, oh, you try to build on CI and then it's going to break. And the answer is no. The answer is definitely no, because this is also what smart release is there for. You know, I spent unfortunately considerable time implementing this, but it works. This means that if there is any kind of change in the lower tier, in the lower level crates, then this change bubbles up to the higher level crates. So if git ref changes and there is a breaking change, but it's exposed in Git repository because it's part of the kind of API there and some types are used directly, then depending on your setup, you might see that breaking change. So if git ref has a breaking change, but Git repository only has a patch level adjustment, then you will still be exposed to this instability, to this breaking change. And that is not nice. However, with Cargo Smart Release, that breaking change will be propagated through all the dependencies. So Git repository will also receive a major a major release or receive a minor release, whatever is considered breaking in somewhere. And this means you don't automatically get the latest version. You will have to upgrade by hand, which gives you a chance to read the change logs and kind of be prepared. This also means that I will regularly release potentially breaking changes. So you will see, hey, maybe 2-3 new minor versions in Git repository, even though maybe it's something you never notice. Maybe it's something fewest notice. Maybe it's something that will require you a little change, but it's only a change at a time. So if you want to, you can even upgrade one breaking version at a time and then only be exposed to a small set of changes that are actually breaking you. So this is the preference of Git Oxide, to make these breaking changes and to make them often. But depending on where you look, it might just be small or nothing, and you can always take many steps if you don't have that much time, and it really does affect you. So I think gives you more opportunity or more choice in how to deal with these inevitable breaking changes, which as soon as possible won't be happening anymore. But I think you really only know that once you've written that server that really will require everything of Git repository to work nicely and of all the plumbing crates and to feel good. And maybe, the more crates are replacing Git 2 with Git Oxide, if the feature set is matching, that this might also trigger changes, maybe breaking changes that then trickle through. So it's a tough time, I guess, because every new customer, so to say, every new user, not customer, every new user of that library, but considering them customers means they're king, of course, which they are. This means that it will take time to stabilize, but I guess with every new client, it will show that yes, this is now actually nice and that is stable, that particular feature. And as you move on, you get there. But it's a big API surface, so it's some work ahead of all of us. That's for sure.
It's going to take some time, yes.
But hey, we are ready, and I hope to see you again for another session soon.
Looking forward to it.
Thank you very much, and see you then. Bye-bye.
Bye-bye.